Welcome back to Three Inquisitive Kids. My name is Karen, one of the recorders on this channel. In this lesson, we will be learning all about proportional linear functions. Chapter 4. Learn all about the concept of proportional functions. As you can see, this is the second lesson of Unit 4. So in the previous lesson, we had the introduction to functions where we learned about the basic properties and the concept of functions. Now we're going to look at something called proportional linear functions. Learning goals. Understand the concept of linear functions and proportional linear functions. Able to write the relational expression of a function. Let's first look at this. Let x represent the number of toads. Let y represent the number of mouths, eyes, legs, and splashes respectively. Can you write down the corresponding relational expressions? So say there were two toads, or two frogs, whatever, two animals. So two toads. How many mouths are there in total? Well, there would be one mouth per toad, so that would be y is equal to x. Each toad has two eyes, so for that it would be y is equal to 2x. 4x because each toad has 4 legs, and y is equal to kx because you don't know how many splashes each toad will make. So that would be y is equal to kx. These are called the relational expressions of these functions. Linear functions and proportional linear functions. In real life, many things can be attributed to function problems. Can you give some examples? So in your everyday life, what movements or changes or problems can you describe with functions? Well, here's one scenario. The natural length of a spring, so one of those sort of like so those bouncy things, a spring is 3 centimeters. Within its elastic limit, so elastic limit means basically the limit of how far you can stretch it. The length of the spring, y, increases by 0.5 centimeters for every 1 kilogram increase in the mass of the suspended object x. So you could think of a spring and it's attached to this object, and the object's weight is pulling down on the spring, causing it to become longer. So if the mass of the suspended object is 1 kilogram, 2 kilograms, 3 kilograms, 4 kilograms, and 5 kilograms respectively, fill in the following table. Well, according to the information we're given, we know it starts with 3 centimeters. And with each increase in kilogram, it increases by 0.5 centimeters. So it goes like this, 3, 3.5, 4, 4.5, 5, 5.5. So now can you use this table and write the relational expression between x and y? That would be y is equal to 3 plus 0.5x. So y here represents, again, the length of the spring, and the x represents the mass of the suspended object. So what this equation is talking about is the length of the spring. So it starts with 3, right? Because it starts at its natural length of 3 centimeters. And then with each additional kilogram in the mass of the object, you add 0.5, so plus 0.5x. There's also another example, scenario 2. There is 60 liters of oil in the fuel tank of the car. It is known that the fuel consumption of the car is 6 liters per 50 kilometers. So every 50 kilometers that you drive, you consume 6 liters of fuel. Again, complete the following table. Along the top, we have the distance driven in kilometers, and this is x. And on the bottom, it's y, which represents the remaining fuel left in the tank. So we know it starts with 60 liters. So when you haven't driven anything yet, so at the very beginning, you start with 60 liters. And then with every additional 50 kilometer that you drive, you have to subtract 6 liters to the 60. Again, can you find the relational expression between x and y? Well, that would be y is equal to 60 minus 0.12x, because you start with 60, and 0.12 is just the decimal version of 6 divided by 50, so turning this fraction into decimals. The two relational expressions of the previous questions is y is equal to 3 plus 0.5x and y is equal to 60 minus 0.12x. So let's discuss. What do you notice about both of these functions? Okay, so you may notice that they both have a constant term and they both have a term with a coefficient. So that may be what you're noticing. And there's also a structure to this as well. So on the right side, for example, you have, again, this constant term, and then you have a variable a variable with a exponent of 1 and a coefficient in front of it. So here's a conclusion based on your observations. If the relationship between two variables x and y can be expressed in the form of y is equal to kx plus b. So here k and b are constants and k does not equal 0. Then y would be called the linear function of x. So here, in both of these examples, y is a linear function of x. X is the independent variable and y is the dependent variable. So we learned about what independent variables are. Independent variables, to review, are the variables that change on its own. Dependent variables are the variables that change based off of the value of another variable. Okay, when b is equal to 0, then y is the proportional linear function of x. So when b is equal to 0, b here, as you can see, is the constant term. So it's saying when the constant term is 0, or when you don't have a constant term, y would be called the proportional linear function of x. So here, neither of these are the proportional linear function of x. So you can think of proportional linear functions as a type of linear functions. Keep that in mind as we look at the following problems. Out of the following, which ones are linear functions? Which ones are proportional functions? Here you have 6 functions listed out. So I'm going to go over them, and using the definition we've just went over, think about whether they are linear functions or proportional functions, or if they are neither. Pause the video and think about this for yourself before coming back and going over it together. Alright, so this first one, it is a linear function but not a proportional function. So if it is a linear function, why is it a linear function? Well, because x does not have a coefficient of 0, and it's to the power of 1. Okay, but it is not a proportional function because its constant term is not 0. Here its constant term is minus 4. If instead it was just 0, it would be y is equal to negative x, which means it would have been a proportional function. Number 2 is neither a linear function nor a proportional function. Why? Well, first of all, you have to think that a proportional function is a type of linear function. So if it's not a linear function, it cannot be a proportional function either. And here it's not a linear function because the variable here, x, it is being squared. And in linear functions, the exponent of the variable has to be 1. So this is not a linear function. Number 3 is both a linear function and a proportional function. So you might think at first that it is not a linear function because you might think it has 2 independent variables. But remember, pi is not, it may be a symbol that's not 1, 2, 3, 4, 5. It may not be sort of what you're used to seeing as a number, but you have to know that pi is a constant. Pi is equal to 3.14, I think it's 19, and then it's it's also a number, okay? So you have to think of pi as part of the coefficient of this term. So yes, it is a linear function, and in fact, it is also a proportional function because it has no constant term. Or in other words, the constant term is equal to 0. Number 4 is both a linear function and a proportional function, just like the last one. Because here, this term here has a coefficient of -1/2, and it has no constant term. Number 5 is neither a linear function nor a proportional function, because remember, a linear function has to have whole expressions on both sides of it. And the definition of a whole expression is that there is no variable on the denominator of a fraction. And here there is, so x is on the denominator of this term, meaning it is not a whole expression and this is not a linear function. And now this next one you might say it is not a linear function, but in fact it is a linear function because you first see, so what many people might think is they look at the 8x squared and they just say, well, a linear function can't have squares in it, meaning it is not a linear function. But you have to think, can you simplify this any further? Okay, so we're judging these based off of its simplest form. So you'll find that if you do use a distributive property and you distribute this x into its parentheses, you'll end up with a negative 8x squared, and then it'll cancel out, leaving you y is equal to x. So always make sure to simplify and see if you are looking at its simplest form before you determine it. So actually its correct answer is it is both a linear function and a proportional function. So again, I think out of these the most confusing was 3 and 6 because in 3 many people you're just not used to the fact that pi is in fact a constant number. So just always be aware of that. And for number 6, always make sure to simplify first. Simplify to its simplest form. Method conclusion. Conditions for determining linear functions. Well, the independent variable has to have an exponent of 1 and the coefficient of the variable is not 0. Conditions for determining proportional functions. The coefficient of the linear whole term is not 0 and the constant term is 0. Let's do some problems. Find the relationship between y and x in the following questions and think, is y a linear function of x? Is it a proportional function? So here's our first one. A car travels at a constant speed of 60 kilometers per hour. The distance traveled is a relationship between y in kilometers and travel time, x, meaning hours. So from d, distance is equal to s, speed, times t, time. So this is a very important formula for itinerary problems that you should know by now. We know y is equal to 60x. Yes, y is both a linear function and proportional function of x. Because, again, it is a linear function and it does not have a constant term, meaning it is a proportional function as well. 2. The relationship between the area of a circle, y, so this is in centimeters squared, and its radius, x centimeters. So find the relationship, and I want you to pause the video and see if you can solve this first. Alright, so what is the formula to finding the area of a circle? Well, that would be y is equal to pi x squared. And here, y is neither the linear function nor proportional function of x because a square is in there. So you have to, in order for it to be a linear function, the independent variable has to have an exponent of 1. In a pool, there is 15 meters cubed of water. The inlet pipe, so the pipe that pumps water in, starts filling the pool at a speed of 5 meters cubed per hour. X hours later, this pool would end up with Y meters cubed of water. So I want you to try to write in a relational expression that expresses this situation. Well, the amount of water in this pool increases by 5 meters cubed per hour. After X hours, it would have increased by 5x meters cubed of water. So this means y is equal to 15 plus 5x. Therefore, y is the linear function of x, but not the proportional equation of x. Okay, so here I'm going to change something. It is not equation. This is function. Okay. Next slide. I want you to sort of look at this solution here. So the question is, it is given that y is equal to m minus 5 parentheses x m squared minus 24 plus m plus 1. And we know that it is a linear function. Then find the value of m. Well, because it is a linear function, we know that m squared minus 24 is equal to 1 and m minus 5 cannot be equal to 0. Therefore, and also m can be positive or negative 5, but m cannot be equal to 5, so m has to be equal to negative 5. Therefore, when m is equal to negative 5, function y, so this function is a linear function. Okay. If it is a proportional function, then find the value of m. Well, because we know that this has to be a proportional function, it will also have to be a linear function. So again, m squared minus 24 is equal to 1, m minus 5 is not equal to 0, and m plus 1 is equal to 0. M is equal to positive or negative 5, but m cannot be equal to 5, so m will be equal to negative 1. This value of m does not exist because it says here that m can be positive or negative 5, but m cannot be 5, so then m will have to be negative 5. But here it also says m is equal to negative 1. That contradicts. M cannot have two values. This means this does not exist. This value of m does not exist. And it would not work if this is the situation. Therefore, this function cannot be a proportional function because it doesn't make sense. M cannot have two values. So method conclusion. If the function is a linear function, then k is not equal to 0, and the exponent of the independent variable is 1. When b is equal to 0, or when the constant term is equal to 0, the linear function is a proportional function. Challenge exercises. If y is equal to m minus 2x to the power of absolute value of m minus 1, if this is a proportional function, then what does m equal? And 2. If y is equal to m minus 1x plus m squared minus 1, and this is a proportional function, then what does m equal? Pause the video and use the definition of proportional functions to help you solve. Well, given that it is a proportional function, m minus 2 cannot be equal to 0 because, first of all, the coefficient cannot be equal to 0. So this is the coefficient of x, so this cannot be equal to 0. We also know that its exponent has to be 1, meaning that this expression has to be equal to 1. Now we're just simplifying, and then we narrow down the solution to m is equal to negative 2. So m is equal to negative 2. And now using the same step to solve this next problem. We know m minus 1 cannot be equal to 0 because this is the coefficient of the independent variable, and m squared minus 1 is equal to 0 because it cannot have a constant term, and in order for it to be a linear function, it cannot have a square in there. So this will also have to be equal to 0. And then once we simplify that, m is equal to negative 1. So the answer to the second question is m is equal to negative 1. Step up training. We're almost there, I promise. As shown, triangle ABC is an equilateral triangle with a side length of x. So this tells you that each side has a length of x. Find the relational expression of the function between the height on the BC side and x. Is h a linear function of x? If yes, please indicate the corresponding k and b values. What does k equal, which is the coefficient, and what does b equal, which is the constant term? Well, the height on AD, so the height AD on BC, this line right here, is also the midline on BC because we know it is an equilateral triangle. Therefore, BD is equal to 1/2 of x. In right triangle ABD, according to the Pythagorean theorem, we know h is equal to AD, which is equal to the square root of the difference of AB squared and BD squared. Solved, h is equal to square root of 3 over 2x. So this is the final solution. H is a linear function of x, k is equal to the square root of 3 over 2, and b is equal to 0. 2 more questions on this problem. When h is equal to the square root of 3, find the value of x. Well, all you have to do right now is substitute that value into this function, and then you can solve for x. So that would be x is equal to 2. And the relational expression between the area S of triangle ABC and x, find the relational expression. Is S a linear function of x? Well, all you have to do is use the triangle area formula. Substitute the values in, and then you can determine whether it is a linear function or not. And here, since x squared pops up, it means that S is not a linear function of x. So, you finally made it to the end, and you should be very proud of yourself and give yourself a pat on the back because those were some really complicated and challenging problems based on proportional linear functions, which is, I know, it could be sometimes a really hard concept to grasp. So, a review on what we did in this class, the class summary. We learned about the concept of linear functions, the concept of proportional linear functions, as well as the functional relationship of linear functions. We understood the concept of linear functions and proportional linear functions, and were able to write the relational expression of a function. So go ahead and click that subscribe button if you haven't yet to our Inquisitive Kids channel. We would love to have you back, and if you think this video helped you, and if you enjoyed it, also please go down below and click the like button. We really appreciate it. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.